Hello, welcome to the presentation on our paper entitled Outcomes of Deep Neural Network Hyperparameter Tuning on Bengali Speech Token Classification. So these are the outlines of my presentation. Starting from background, I will be describing these topics one by one, like literature review, the problem we solved, the way we solved it, and what is the result we achieved so far. So let's start. Starting from background, so we know that Bengali is the sixth most spoken language in the world, but in a broader sense, we know that there are still a lot of challenges if we want to use Bengali in real human-machine interaction devices like Google Assistant or Apple Siri, Alexa, Cortana, and so on. So in a broader sense, we could say that yes, there's a lot of research needs in our Bengali language. Now, in case of speech recognition researches, so we will find that most state-of-the-art researches involves a deep neural network, at least in a few extent. Now, speech token classification, the thing we focused, it has several crucial applications, of course, like emotion recognition, then speech dictation in vehicles, smartphones, and laptops, then home automation, then assisting physically challenged and oldest people. Now, in case of speech token recognition, one of the things that we often do is we extract information or features from raw speech. So there are different feature extraction techniques. One of the technique is formal frequency, which is basically the resonance frequencies of our vocal tract when we are speaking some things. So we can say that the formal frequencies are F1 to F5. The five frequencies are mostly considered. Now, probably you noticed that our title has hyperparameters. So what do we mean by hyperparameters? So these are some specific settings that needs to be configured while configuring the DNN model. Now we focused on three specific hyperparameters. The first one, optimizer. So optimizer basically minimize or maximize at some cases as well the cost function. So depending on the type of the cost function, it needs to minimize or maximize, and it's targeted to optimize parameters of a DNN model. Now, what are the parameters? Parameters are weights and biases. Now, another hyperparameter, which is batch size. So it basically refers to the number of training sample passed at once while optimizing, or we could say while training. Now, next thing, dropout. So overfitting is quite a common phenomena in this sort of classification problems. Now, to reduce overfitting, we basically apply dropout. So dropout basically randomly makes some neurons at zero. So it reduces overfitting. That means it reduces the distance between training and validation scores. Now, if we review few literature, so mostly on speech token classification using DNN, so there are some specific research like Yusuf and others, they classified 5 Malaysian vowels using DNN. Also, reference 5, they classified read and conversational speech of 4 Indian languages, including Bengali. They also used a multi-layered DNN for phoneme recognition. And reference 6, they classified English command words using DNN. And if we talk about format frequency features in several literature, so we'll find like Malaysian vowels, they used, while classifying Malaysian vowels, they use those format frequency, like classifying Turkish vowels in reference 10, they used format frequency, and finding the place of articulation by reference 11, they also used format frequency. So we could say that format frequency are one of the widely used features. Now, what is the gap that we are trying to solve? So most researchers that we so far reviewed, they have reported their specific model and performance. And sometimes they report few outcomes on 1 to hyperparameter variations, but this is not so comprehensive. I mean, this is not so wide range applicability. So in contrast, we report comprehensive result, as I was saying, on 3 specific hyperparameters that I just mentioned, and also indicate which hyperparameter to select in similar studies. Now our problem statement, so as I was saying that we'll be focusing on DNN. Now one of the critical steps in implementing DNN is to select optimum values of hyperparameters. Now we would reply this question: in isolated Bengali vowel and word classification, what would be the optimum value of those 3 hyperparameters? So this is our question that we want to answer. Now, objectives, of course, so we present comprehensive result on 3 DNA hyperparameters tuning. We recommend a set of optimum hyperparameters from our study, and also we demonstrate a pipeline, classification pipeline that can classify speech sounds to different classes. So starting from form and frequency features, so we'll be showing about the evaluation results. Now, in methodology, if we first talk about data sets, so we used 7 isolated vowels and 7 isolated words. And each classes, we have 40 samples. So in total, we have 560 samples. Now, 5 form and frequency, they are extracted using Pratt script. And as those features had values at different ranges, so we standardize them according to this formula. This is basically subtracting the mean and divided by standard deviations. Now, this is the specific DNA architecture that you used. Here, all those 4 hidden layers has canase activation functions. And this is the input, the 5 form and frequency. And in the output, we have 7 vowels for vowel classification and 7 words for word classifications. Now, in the simulation results, we could talk about when we change the optimizer. So if we first use the ADA delta optimizer, we can see that the validation accuracy is roughly around 80% or more, 85 or 6%. Whereas when we use RMS prop, then the accuracy got decreased to around 80%. And if we use ADAM optimizer, so the accuracy decreased even more, roughly around 65%. So we could say that ADA delta optimizer performed best here. Now, in case of batch size, so if we use the 128 batch size, so this is the validation curve, roughly around 80% accuracy. If we use 200, then the accuracy got decreased. Now, if we use 256, the accuracy is roughly around 80%. So it is quite equal to 128. Now, if we talk about changing in dropout, so as I was saying that dropout reduces overfitting, that means that it reduces the distance between training and validation scores. Now here the single dropout value, so these are basically applied after the first hidden layer only, whereas these two value, that means this first value is applied on the first hidden layer and second value after the second hidden layer. Now if we notice, the difference does reduce here. If you notice, like the differences is reducing when we increase the dropout rates. But at the same time, the validation accuracy is also accuracy is here, so loss is there and accuracy. So validation accuracy is also being decreased. So of course, we care about validation accuracy. So we need to balance between these two things. I mean, the overfitting and validation accuracy. So to balance this between this validation accuracy and overfitting, so we recommend an dropout rate between 0.2 to 0.4 since the accuracy, validation accuracy, and also the overfitting is quite at a reasonable level. We could also observe this thing in a graphical manner. Like if we notice, like here 0.25 is the dropout rate, and when we are increasing, so overfitting is being decreased, and also the validation accuracy here, it is also being decreased. Now, if we talk about outcomes and impact, so of course the outcome, we found that ADA delta optimizer that performed better with classification model at batch size 32. Then we find that in terms of batch size, 128 and 256 performed better. And also the validation accuracy on all those 3 different batch sizes, on 28, 200, 256, they are roughly same. And we recommend a dropout rate between 0.25 0.4 after only the first hidden layer, and we don't recommend dropout after second and third hidden layer from our studies in these scenarios. And of course, we present a Bengali speech token recognition pipeline starting from form and frequency to the final result. And impact, so we think that this DNN formed by utilizing this recommended hyperparameters, so that should be a potential pre-configured speech classifier. So future research on similar classification may directly employ these things, or at least they can get a hint on where to tune. So in conclusion, we could say we report 3 hyperparameter searching outcomes. We used form and frequency in a 4 hidden layer DNN. We recommend ADA delta optimizers and batch size this and dropout value this we just discussed. Future research plans, so we could employ other DNN structures like CNN, RNN that would improve the classification performance. We should also be able to report comparable performance. So these are the references, and with that, I'd like to end here. Thank you for hearing me.